Hello, space enthusiasts, and welcome back to our channel. Today, we're journeying hundreds of millions of miles away to investigate a celestial mystery that's unfolding right before our eyes. We're talking about Jupiter's most famous feature, the Great Red Spot. This colossal storm, a swirling crimson vortex wider than our entire planet, has captivated astronomers for centuries. But something strange is happening. The Great Red Spot is shrinking, and it's doing so at a startling rate. This raises a fascinating question. Are we witnessing the final days of this iconic tempest, or is something else entirely going on? For as long as we've had telescopes powerful enough to see it, the Great Red Spot has been a permanent fixture in our view of Jupiter. It's an anticyclone, a high-pressure system so immense that you could fit Earth inside it with room to spare. Its winds rage at speeds over 400 miles per hour, making it the most powerful and long-lived storm in our solar system. Imagine a hurricane on Earth, but one that's been churning for at least 150 years, and likely much, much longer. Some early observations from the 1600s might even be referring to this very storm. It's a true giant, a testament to the sheer scale and power of planetary weather. But this giant is getting smaller. Back in the late 1800s, observations estimated the Great Red Spot to be about 25,000 miles wide. That's more than 3 times the diameter of Earth. By the time the Voyager spacecraft flew by in 1979, it had shrunk to about 14,500 miles. Still massive, but a significant reduction. Fast forward to today, and images from the Hubble Space Telescope and the Juno mission show it's now only about 10,000 miles across. It's gone from a wide oval to a more circular shape, and it's continuing to contract year after year. So, what's causing this cosmic diet? The truth is, we don't have a single definitive answer yet. Jupiter's atmosphere is an incredibly complex and chaotic place. The Great Red Spot is like a spinning top, but one that's interacting with countless other currents, jets, and smaller storms in the atmosphere. One leading theory suggests that changes in the surrounding atmospheric jet streams are playing a role. These powerful east-west winds might be altering the dynamics that feed and sustain the storm, effectively chipping away at its edges or reducing the energy that keeps it going. Think of it like a river changing its course and slowly eroding the land around a massive whirlpool. Another fascinating observation is that the storm isn't just shrinking, it's also getting taller. As its horizontal footprint gets smaller, the vortex seems to be stretching vertically. This could be a sign of the storm reorganizing itself, conserving its angular momentum in a new configuration. It's like a figure skater pulling their arms in to spin faster and taller. The storm is changing shape, not just fading away. We've also seen strange events happening on its periphery. In recent years, astronomers have observed what they call flakes, or blades peeling off from the edge of the Great Red Spot. These are smaller reddish cloud systems that are torn away from the main vortex and get swept up into the surrounding jet streams. For a while, it looked like the storm was unraveling. Every time one of these flakes detached, scientists wondered if it was the beginning of the end. However, the Great Red Spot has proven to be remarkably resilient. Despite these losses, the core vortex has remained stable and intact. It seems to have a knack for surviving these encounters. This leads us to the biggest question of all. Will the Great Red Spot disappear completely? If the current rate of shrinkage continues, some models predict it could become a mere circle within the next 20 years, and potentially vanish altogether sometime after that. It would be an incredible and somewhat sad thing to witness, like watching a centuries-old monument crumble into dust. The end of an era for planetary science. However, there's another possibility, one that's just as compelling. Perhaps the Great Red Spot won't just fizzle out. What if it's evolving? Some computer simulations suggest that as the storm shrinks, it might not disappear but instead break apart. It could split into several smaller, but still very powerful and long-lasting vortices. We've seen this happen with other, smaller storms on Jupiter. These baby red spots can persist for years or even decades on their own. So, the Great Red Spot might not be dying, but rather preparing to reproduce, spawning a new generation of storms that will continue to drift through Jupiter's turbulent clouds. This scenario is particularly exciting because it reflects the dynamic nature of giant planets. Storms are born, they merge, they grow, and they decay. The Great Red Spot could be part of a much longer cycle that we are only just beginning to understand. It might have grown by merging with smaller storms in the past, and its current shrinking phase could just be one part of its long and complex life story. Thankfully, we have an amazing tool on the scene right now: NASA's Juno spacecraft. Since arriving at Jupiter in 2016, Juno has been making incredibly close passes over the planet. Flying directly over the Great Red Spot, its instruments can peer deep beneath the cloud tops, measuring the storm's structure, temperature, and chemical composition in unprecedented detail. Juno has revealed that the roots of the Great Red Spot run deep, extending hundreds of miles into the planet's atmosphere, far deeper than anyone expected. This deep structure might be the key to its longevity and could hold the clues to its future. The data from Juno, combined with long-term observations from Hubble and ground-based telescopes, is helping scientists build more accurate models of what's happening. We're trying to understand the balance of forces at play. Is the storm losing more energy than it's gaining from smaller storms it absorbs? Are the surrounding winds strangling it? Or is this all just a temporary phase in a cycle that spans millennia? So, while the headlines might suggest the Great Red Spot is on its deathbed, the reality is far more nuanced and exciting. We are witnessing a fundamental process of planetary atmospheric dynamics in real time. Whether it vanishes into the history books, transforms into a family of smaller storms, or stabilizes at a new, smaller size, its evolution is teaching us invaluable lessons about how these giant worlds work. The story of the Great Red Spot is far from over. It's a Levoxian science experiment on a planetary scale, and we have front row seats. What do you think will happen? Will it fade away, or will it split apart? Let me know your theories down in the comments below. It's a mystery that keeps us looking up and wondering. Thank you so much for joining me on this journey to the King of Planets. If you enjoyed this deep dive into the cosmos, please give this video a thumbs up and consider subscribing to the channel for more space adventures. Hit that notification bell so you won't miss our next exploration. Until next time, stay curious.